All right. Today I have Cole Evans. He's the CEO of Enduro Metals. Thanks for taking the time to out of your day to chat with me, Evan. Sorry, Cole.
Yeah, that's okay. That's all. People call me Evan all the time. No worry. Yeah, no. Likewise, Andrew. It's good to be able to chat with you again. I know we got a chance to chat once earlier in the year, but of course we've all been up in the field for the last or
4 months, right?
yeah. I'm starting to lose track of time here. You start to go a little crazy when you're up there for too long. But yeah, for the last 4 odd months.
Yeah,
But,
that's
yeah,
it.
we've been busy, obviously, over that time.
Yeah, that's great. So I want to talk to you today, maybe for those who haven't heard your story before, if you want to give a quick introduction about Enduro, who your company is, and your property.
Yeah, definitely. Yeah. So Enduro Metals, we're a junior explorer located right in the center of the Golden Triangle. It's our 638 square kilometer land package. You can see outlined here in the red, right along a really productive corridor that we like. That's wedged in between Galore Creek up to your northwest end, and then your KSM camp on your southeast end. Of course, with the SK, SNP, all the deposits. I know your listeners are well familiar with the Golden Triangle that fill it all in between. But for what we're talking about today, which is going to be porphyry focused, this is a really important trend for a lot of reasons. It's our parallel along here, but porphyry. The porphyries in and of themselves are not rare deposits. What's rare about them are the conditions to form big ones. And that's one of the things that makes the Golden Triangle such a special area for mineral exploration and mining compared to other jurisdictions in the world, is it has those, there's a long list. We'll touch on a couple of them here in a little bit, but it's that very unique area that has all those pieces put together to be able to form the big porphyries. And that's obviously what we're focused on with Enduro Metals, is to where is the next tier one porphyry deposit that hasn't been found before. And from a very high level, one of the best places to look would theoretically be right in between the two existing ones.
Yeah. Okay. Yeah. So I guess so. You guys put out a news release early this week, and it was basically a discovery hole at Burgundy Ridge. You guys drilled 331 meters of 0.7 copper equivalent, which is absolutely stunning. For our first hole, it was 001, so it's a first hole of the season over there. So
yeah, maybe first hole on that target. We drilled elsewhere earlier in the season, but yeah, sorry, first hole on that target. Yeah.
All right. Yeah. So maybe you can step us through that news release, talk through some of the cross sections and some of the maps, and really, I wanted to spend some time to dig through it and dissect it.
Yeah, absolutely.
Sorry about that.
No, that's all good. Yeah. So yeah, no, definitely. Let's right from the top. That's one of the things in press releases, is you're trying to condense it into the short and sweet version to catch the attention span of most people reading. But in doing so, it's hard to extract important information out of it, particularly on a project that's early stage like ours is, right? We're the only company to have ever drilled this area ever in human history, the Burgundy Ridge target. And that the first diamond drill holes were in 2019. And actually, if you don't mind, Andrew, I'm going to show your viewers something that I was wanting to include, but again, for the sake of space, hopefully you can see this.
Yep, I can see it.
Okay, so this is just to give a little more context. All this is public information you can find on our website, but what I've done is just put it all together. And to be quite frank, I'm not a huge fan of the copper equivalent numbers. The reason I do it is if you're trying to put everything in here, this is already such a messy screen. It's unreadable if you try.
Yeah, absolutely. You have so much other stuff in there as well, right?
Yeah. So so just to simplify it down, but the full numbers are available on our website for those who want to see them. But to give a little bit of history into this discovery hole, is as I mentioned, going back in 2019 was the first time that we drilled this area with, what we call a first pass program. So typically, relatively shallow holes, trying to get some decent spacing. And you can see you'll build a single pad and you're drilling out in these wide fans, trying to cover as much area as possible with as few meters as possible to get a general idea of what's going on. And this is where we saw the smoke. And you can see, some of these numbers are pretty good in and of themselves. 91 meters, 0.61 copper equivalent, or breakdown that was 0.38 copper, 0.3 gold. So good numbers that we're seeing through are what we've highlighted in red here as being our important trend. And that was the smoke that sort of led us into making this discovery, which you can actually see is completely where we've actually drilled it is well underneath the ice and snow, maybe about 100 meters away from the edge. So that's an important thing to point out. A lot of people think that the ice ends up representing like you're not able to target under it or things like that. It's definitely more challenging, but it's not it's not a showstopper, if that makes sense.
Yeah,
and hopefully this is proof of that. But yeah, so that was our smoke that led us into making this discovery. And of a particular importance was our channel sample in 2019. And if I pop over to this screen here, I'm just going to skip through lots of these slides and get into where we have a breakdown here of a couple different intervals. And what we saw going on there is we have this breccia, or what we call the green rock breccia, or technically I just call it the sphalerite cemented breccia. We found 4 different mineralized breccias thus far in this area, and that's where you're pulling some of this higher grade material right in here. So that's where you're getting your 22 meters at 2% copper, 4.7% zinc, 2.2 grams gold, 34 grams silver within that. And then you can see there's just a little post-mineral dike, virtually unmineralized, a little bit of enrichment, but nothing significant. And then we could start to see this portion, this last 7 meters here, which, yeah, from a numbers perspective, not as significant, but from an alteration and bigger porphyry perspective, here's an idea of some rep samples here for your viewers to see what those last 7 meters looked like. It had, as I always say, the right burn to it, the right alteration. And porphyries are all about alteration. These are big hydrothermal, vertically oriented hydrothermal systems that move a lot of fluid. Hydrothermal fluids, fancy word for hot water, right? Move a lot of hot water through the ground and over geological time are burning, literally burning the rock, altering the rock. So you want to look for the right alteration to vector you in, and this was the right looking stuff that kind of gave us a hint as to, okay, there's something interesting going on. And this was right to the edge of the ice. Of course, the mineralization kept going, but like you can see,
okay, it's underneath. Yeah, exactly. You couldn't channel sample underneath the ice, obviously.
Exactly. Yeah. You could literally, it's funny the way it melts, because it's melting from the ground up, right? The ground is heating. And so I literally had my head and flashlight wedged underneath the ice. There's about a 2-foot gap and I could see it keep going. I'm flashing my flashlight down as far as I could go. I wanted to just keep crawling under the ice, but better judgment decided not to. Yeah, so that's essentially what led us on to it.
Okay, so yeah, that's a great context. Yeah, and I guess from the news release here, you've also mentioned that you think that this hole is just on the fringes of a very big system, that you haven't tested those portions yet. Could you kind of explain why you think you've just hit the fringes and where you think some of the even better stuff might be?
Yeah, absolutely. That it goes back to that burn question. That is one answer to the whole story, but it goes into the alteration that we're seeing. We're starting to see that transitional, or that development into our hotter assemblages. Think of porphyry deposits. Of course, they thrust and shift, and after the mineralization events have occurred, they move around. So they're not as simple as what I'm going to explain. But if you think of your traditional porphyry deposit model, it's all based on concentric zonation. So you want to think of it generally like that concentric zonation, with where you're finding the center of it, it's getting hotter, and you're looking for that right burn, as we discussed before, that indicates that you're in the center of the system. Particularly important for alkalic porphyries, which is what this is. This is what we call a silica undersaturated alkalic porphyry system. Reason why that's important is because they're typically higher grade than a calc alkaline system. You usually have different metal assemblages. A calc alkaline system would be your more, I call it traditional porphyry, copper moly porphyry. So your alkalics are typically higher grade. They're usually smaller in tonnage. Again, just generally speaking, of course, there's still big ones, Galore Creek being right beside us, over 800 billion tons, 1 billion tons, depending on how you cut the resource. But they're moving less fluid than the calc alkaline ones. The point being why all that's important is they're usually harder to find, and why the alteration is critical to understand. And that's where we got a lot of help this year, actually, from Dr. Alan Wilson, who came up on site, which we announced earlier in the season, to help us really narrow in our alteration assemblages. And that's part of the framework into why we think we're on the fringes of the system. Another thing too, and it's been kind of a question mark for a lot of people that I've talked to that didn't really understand it, was the zinc content. Why are we seeing zinc in a porphyry system? And what a lot of people might not know is actually one of the most common means of lateral vectoring for porphyry system is a copper zinc ratio. And why we do that is because think of copper as just being a higher temperature metal, right? Getting into the center of our porphyry system, with zinc being a lower temperature one that we're going to see on the fringes. So we can ratio those numbers into, obviously, when you're seeing a higher ratio, okay, it's an indication that it's getting hotter. So the fact that we're getting the grades that we're getting when we break down the individual metals, which is important, like we can see here, you take that 206 meter interval, those copper and gold grades are comparable to any of your copper gold porphyry resources in the area. Or if I make any comparisons, then I'll take the most recent one, GT Saddle, only because I think they did an incredible job with that discovery. But your numbers are 330 meter interval. That's almost identical to their indicated resource grade, and higher grade than the inferred resource grade. Of course, we're earlier stage, right? But that's kind of the exciting part of the whole
exactly.
thing.
Yeah. And you've got a huge intersection to start, and you've got a kicker bonus of the zinc as well, right? Which is kind of flying with all the other base metals. The
zinc is not really a focus for us. Why I say it is important when we're saying on the fringes is the fact that, okay, if that zinc is still kicking around that lower temperature metal, as we vector what we think is to the northeast is the direction that we need to be moving. That, in theoretically, and we already see it, it's not really that theoretical, because of course, if we go back to that plan view image where we already have our short feeler holes up in that direction, we see a lot less zinc out there. So our idea being that as we're getting down into the part of the system where we want to be, essentially these holes would have drilled over top of where we want to be, or we're either beside where we want to be. Hole 4 is a really good vector kind of showing this, where you can see, so we're in, there's a couple little random high grade things going on here, not super significant, but hole 4 is actually a really good hole that it from an investor intercept perspective, no, not significant. From a geological science perspective and putting a deposit together, very significant, because it shows a really good concentric zonation, that transformation of different alteration assemblages as we move towards our target area. And of course, you can actually see too in our copper and gold, it's starting to pick up as the hole keeps going, but it's still a little bit, still a little too far off to the northwest from where we want to be. So we think we've got to move up in this direction here and just simply get down deeper below where these holes were. Because another thing that's hard to get perspective on when you're looking at plan view maps is where this drill hole and trench is actually about vertically 120 meters below where these holes up on the top of the ridge were, right?
Oh, right. Yeah, because of the elevation on the mountainous area, right?
Exactly, right? So that we're coming down slope here. So we have the advantage of when we're drilling down here that we've already come down 120 meters vertically, which when you're factoring in a hole that, you know, could be at a -65, -75, whatever, that's only up to 100 and, you know, only 150 meters deep. Well, basically the bottom of the hole is where the start of this hole is. So
Exactly.
you're just
Okay.
not down into it, right?
Yeah. So you know where to go. You just got to poke some more holes when you get back to it again. Maybe what like maybe show the scale of this system, right? Like how
Yeah.
I know that that first photo is a little bit zoomed in, but like if you zoom out a bit, like how big is this compared to say like Galore Creek on in terms of like footprint? I know you I
Yeah.
noticed that you had Galore Creek and KSM and some of those circled in your news release as well.
Yeah, so this is a blown up version of the image you'll see in the news release, and that's a really great question. So what we're looking at here is this is a airborne magnetic survey. You know, I believe this is at 200 meter spacing, so relatively coarse. What the magnetics aren't giving you, that's not something that you want to target drilling off of. What it's insinuating is the source batholith. So what a batholith is, it's the big body of rock, you know, the heat engine, for lack of a better way of putting it.
Okay.
Some people will say, but it, you know, it is kind of a true term. It's this big hot body of rock that sits underneath where porphyry deposits form, and basically you have all these dikes that are shooting off the top of it, and that's what's actually. And if you look in our geological mapping, that's what you're kind of seeing. You can see your volcanic and limestone units, right, in the green and blues here, and then you can see all these thin pink and red, purple little dikes that are ripping up through there, right? So these are all sourcing off of the batholith that sits underneath it. That's really important. That gives you an idea of the scale of the heat source that could be driving the system.
Okay. So do you think these it's one big heat system? So do you think that, like, I guess from Burgundy Ridge and 72, those are maybe different systems, but part of the same heat source?
Yeah, you know, it's
Hard to say.
yeah, they're coeval is what we'd put it. They're part of the same greater system, but porphyries form in clusters, right? That the typical of almost all you know, porphyry deposits is you're going to have different porphyry centers within a greater, you know, an example would be if we look at Highland Valley. And it doesn't matter if it's alkalic, alkaline, doesn't matter. If we look at Highland Valley, largest copper mine in Canada, right down the southern interior of British Columbia, you know, there's I believe it's 5 different pits they have there, right? So different centers, you know, Mount Poly, right? Because you have all these different zones, and that's kind of how you need to look at this. Is you've got different zones. You know, we can see even out here as we move to the west, off on the fringes, there's, you know, this Baxter zone, these different centers that are lighting up. When you look at Burgundy Ridge, so the last image that we were just looking at for scale is just this area here.
Yeah. And this is like this is if you're looking across, this is almost, I think, 8 kilometers, maybe, if I'm looking at the legend correctly down there.
Yeah, you're this purple oval here is roughly just over 3 kilometers in length.
Okay, 3 kilometers.
It's about a 2.3 kilometer distance from Burgundy to 72 out here, but and your ridge width here is roughly 500 600 meters. But as you can see, and it might be hard to see in the press release again about how small the image ends up being, but you know, and I can even come in here and oops, maybe that helps. It's zoomed in a little more, but you can see, you know, a red triangle on here is over 1% copper. I've been fortunate in my time as a exploration geologist that, and, you know, in our entire team, we've literally seen thousands of mineral occurrences just in British Columbia. I can with confidence say that this ridge, this area, is one of the most impressive ones I've ever seen. Just in the sheer scale of, you can walk for over 400 meters and consistently see copper oxide, not having to go down on the ground and look for it, but just with the naked eye as you walk. And as this geochemist geochemistry insinuates across the entire thing.
Okay. Yeah.
When we move into this Rock Islands area, of course, it's not shown in the geochemistry yet. But as we get more results, and there's spots here where we're finding more of the same. The copper is here, copper and gold is here, the copper and gold is there. There's smaller centers over here in Talina, but you can see that trend continuing through. So yeah, the scale is real, and it goes back to that alteration we were discussing earlier. It's really a mathematical problem from a geochemical perspective. To get a certain amount of burn, you had to have a certain size fire, if that makes sense.
Yeah.
This area is burnt to crisp. So,
you just
what caused
yeah,
had to have been a certain, yeah.
Exactly.
If that makes sense.
Yeah. And so that's great. Thanks, Cole. That's really helpful. Hopefully that, like, the scale is really, it's huge, right? It's the same size, or if not bigger than Galore Creek. And in the news release, you've also mentioned that you will be putting did you want to go through some of the core as well?
Yeah, if you like to, a thing to maybe pull out for your listeners that you might not necessarily pick up from just looking at the press release, and again, just more evidence of the big porphyry system existing, is this is that first breccia we were talking about that we first channeled on surface, and that was the 18-meter interval of about 3% copper equivalent. And this is just an example of what the core from that 18 meters looks like. And a really important, again, technical, and I know your listeners are more technical as you are, observation to make in this is we can see all this red rock in here. I won't get into exactly what it is, but it's this potassic alteration assemblage, a number of different alteration minerals that are causing this. And an example is you can see vein generation. So you can see how this white vein here, it doesn't cut through this cement. It's limited to the clast, we call it, within the hydrothermal breccia. Well, within there, you can see your chalcopyrite, your copper mineralization from your main potassic, what's likely your main potassic alteration mineralization event. And this breccia, so this cement that has the copper, that the chalcopyrite, the sphalerite, the pyrite, this darker mix that's ripping through it, is essentially ripping up all of this rock that was already mineralized and putting it into a later mineralized, a post main stage mineralization, if you like, breccia. So that gives us, why is that important? That gives us a look into what's going on deeper within the earth, in those areas where we haven't tested, adjacent to where we've drilled, and we can see right from surface that, geez, okay, there is porphyry, hypogene porphyry mineralization that's being ripped up and brought to surface from down there as well by this later breccia. So it's almost like getting a free drill hole for, in a way, right? A free look into what's going on.
Yeah, what's maybe deeper, right? It's kind of bubbling to the surface, or at one time.
Exactly. Without, it just being a concept in your mind. It's like, no, you have actual evidence for it.
Exactly. And I guess, like, for people, again, this is very similar to what's found at Galore Creek. It's a similar size, well, look, the footprints, at least the similar size, right? You got to put some holes in between.
Geologically, we've made the comparisons to it. Saying that it is the same thing right now would be going too far, in my opinion, based on, Galore Creek's a world class, like I said, it's a 1 billion ton deposit. It's had, well over 500,000 meters of drilling into it. We've had, 1% of that, 5,000 maybe. So yeah, so it's
too early, definitely.
It's too early, but we like our odds, and we feel confident that it looks like a duck, quacks like a duck, flies like a duck, and it's in the middle of the swamp.
Yeah, and I guess that's why you're putting the winter roads. I think you put in some in your news release as well. You're going to be spending some time to beef up camp to help through that. So I think it's on this slide here. Could you just walk us through the winter access roads and how that's going to help you guys?
Yeah, so one of the great things, hopefully you can see this inset map okay. With our properties, there's developed road access to the north and south end in the form of the Galore Creek Road that's been complete thus far, and then your SK Creek and your hydroelectric facilities. What I'll do actually, it's easier to see, is we can do it in 3D, because I always make the comparison to people of how we're lucky at Newmont Lake that relative for northwestern BC, we have flat access routes, which is really important when you're thinking of the future development of projects. So here's an example. Here's that Galore Creek. Here's they call it Shione Camp, which means wolf, I believe, in the Tahltan language. That's sitting right here. Well, up into where we're going is a flat U-shaped valley the whole way. I won't draw it up the whole way, but you get the idea.
Exactly,
of which we've surveyed, done our line cutting, all the things that we need to do. All those preparations have been put in place. Our camp and airstrip are out here. Burgundy's up in the mountain here. McClymont's just on the other side. So that gives us a real advantage when it comes to being able to get programs going earlier and also helping drive our costs down. You know, if you're doing a big program where you need to bring in 200,000 liters of diesel fuel, that's really expensive to do 1,000 liters at a time with a helicopter, right?
Yeah.
Which is how projects operate today. Now you can now start bringing it in bulk, 60,000 pounds of equipment at a time. So it drives your cost down, but it also gets rid of that limit of when you're bringing things in and operating by helicopter. You know, the standard helicopters used here by all the explorers in there, you're really capped out at about 2,000 pounds as to what you can lift. So, you know, the idea of bringing in larger excavators, dozers, any of these sorts of things is more or less out of the question. Having winter road access, we're of course able to bring in that type of equipment as well that can help move this forward faster.
That's really excellent, right? I know a lot of people always think that the Golden Triangle is way too remote. You can never have winter access roads is what they think, and like any deposit you find is like really hard to ever mine, right? So maybe you could just want to talk about why you think Enduro here is kind of has an advantage. And I think you've already gone through some of it, but if you have any other thoughts about maybe some examples in the area or any other items that are particularly unique to Enduro and your advantages.
Yeah, well, like I said, if we're just looking at it from a locational perspective, and if we go into a slide from one of these presentations here that kind of covers the whole area. It's right in the middle of, like I said, the heart of where you want to be in that infrastructure development, which is critical to this area. I know you've been up here in this area before when we were chatting, saying that you're down on the SK Road and things like that. So you've been able to see it firsthand as to the development that's going on. That's critical into your mineral economics of a project, right? When this project was really drilled between 1987 and 1990 along the McClymont Fault, you know, you're 75 kilometers away from the road. Access and equipment was actually coming out of Alaska, out of Wrangell. So of course in the US on the other side of the border, having to be, you know, so brought in by boat and barge into Wrangell, loaded up into aircraft, flown into the Bronson, the SNP area, right, when they were discovering SNP, and then from there be helicoptered into places. So incredibly expensive, incredibly difficult. Well, now it's not that. It's not that way. You know, it's like I said, access roads are there. That has, for people, it's hard to emphasize that, or you can't overstate it for people, particularly who haven't seen it and seen the kind of area it is. To be able to have that easy access completely changes the game for your project.
Yeah, that's great. Yeah, so thanks Cole for those thoughts there. And I wanted to know, like, I know today we focused a lot about Burgundy and Burgundy Ridge here, and I didn't want to go through all the other targets because, you know, you haven't put out those disclosures yet through news releases, but I wanted to get your overall thoughts on how the 2021 exploration program went. You were there on site for, I guess, almost 4 months.
Yep.
And I just wanted to see, you know, from the plan that you set out at the beginning of the season, you wanted to drill a whole bunch of targets.
Yep.
How do you feel the 2021 season went?
Good. Yeah. No, our goal when we were discussing going into the 2021 season was this is our part of a disadvantage really of having a large land package as a junior explorer is how can you explore it effectively in capital efficient, in keeping capital efficiency in mind. So we said, okay, well, 2021, this is our last year of the poke around, so to speak, and we've got these targets on these different locations and figure out, okay, what's going to be a standout? What is the target that we can focus on and transition from knowing a little about a lot to a lot about a little, right? And focus in on one area and move that deposit forward. And so, yeah, and I think we've been really successful at that. A good problem to have is when it becomes unclear almost because you got a couple winners, so to speak. But we feel quite strongly in all the knowledge we have now of the Burgundy 72 system that, okay, this has a real chance of being one of these elephant porphyry deposits that this area is known for, that's never been discovered before. And ultimately, we believe that's going to bring the most value to our shareholders because these are, alkalic porphyries, your copper gold porphyries are one of the most sought after deposit types in the world today. And the way we view metal markets moving forward is that that's not going to change.
Yeah, for sure. It's things seem to be getting a lot better in the commodity space these days. So we're definitely looking forward to your next releases when you're able to put out news about your other targets, and I hope that we'll be able to chat again about those and have you back on.
Appreciate it, Andrew. Would love to.